last, final, end of the day speaker is a man who, I'll tell you a quick story. So, Cory Hanes, I first met in Gothenburg, which is a place that you go to meet people, and at a conference called Nordic Ruby. And Cory ran this is the first time I met him. I had heard of Cory Hanes, but he was running a thing called a code retreat, which he invented to solve one of the problems that he discovered from his life of traveling around, pairing with people. So we've just heard about Avi talking about pairing. Instead, he was doing it remotely. Cory would actually go to people's place, their business, and actually pair with them. He would travel around. He had a name for it. It was called the Cory Hanes My Pair Programming Tour. So it never really took off because it's got Cory Hanes in it. Aaron Patterson later on actually called himself Cory Hanes. So the name Cory Hanes has become the symbol. I don't know what it's become the symbol for. Good-looking, sharp man. Cory is, so Cory was one of the first people to sort of say, you know what, I'm getting out on the road. I'm actually going to meet people, I'm going to learn, I'm going to share, I'm going to learn. And so this is why he gets to come and talk and share, because he's got a lot of ideas. Today, he wants to share on design patterns. Please put your hands together for Cory Hanes.
All right. All right, I'm super excited to be here in Barcelona. I was going to tell a story about how hard it was to get over here, but if you follow Avdi on Twitter, mine was like a dream. It was wonderful, so I'm not even going to go into that. I did wake up at 4 a.m. this morning, so I'm a little punch drunk. So let's get started. We got a lot of time or a little bit of time and 108 slides to go through. So what I want to talk about is, let's see, what am I talking about? Design patterns and the proper cultivation thereof. So I wanted to kind of give a feel for sort of my experiences through design patterns over the years. I first learned about them in late 90s, and they've gone through phases of having bad feelings. A lot of people are like, design patterns, horrible. But they're really a powerful thing. They're an advanced thing. But I kind of wanted to just give some thoughts around that as we go. So let's go. So first of all, as every good story starts, there was a time. Actually, good stories start with once upon a time, but this is mine. So there was a time when dinosaurs ran amok, chasing people in canoes. It was chaos. Dogs and cats laid down together. They were friends. It's crazy. We called this time BDP, or before design patterns. It was just mass confusion. Like, what the? If you don't have at least one of the stuff on my animal Twitter stream and your stream, go out and look at like stuff on my dog or stuff on my rabbit. It's glorious. Like half of my Twitter stream is pictures of like pancakes on rabbits. So mass confusion. Meanwhile, in computering, I was, this young guy, great, coming in, doing all this stuff, and I would come into my team in the morning, and I would have built up this big design, and they looked kind of like this. So my designs, clouds were, objects, birds were method calls, and then like lightning bolts were events. So this is a mouse going to this board, which calls move on a note, which moves on its children. And since it's a nature scene, of course, I would draw these things. No lie, this is what my design stuff would come in. And so I'd come in the morning to my team, of course, and I'd say, hey, design review. Now imagine me coming in with this and going, this afternoon I want to get your feedback on my designs. And I would get things like the trees not really appropriate, and the flowers are as big as the tree. But most of the time, it was just people like going, "What? What's going on?" So my team, we got together and we started looking around, and we discovered design patterns in UML and some of the other stuff in the late 90s, and we found that these gave us a common framework to talk about it. So I could come in the morning and not have pictures of trees and clouds and birds and things like that. I could come in with boxes. It wasn't as neat. Occasionally, I would still have birds, but you knew which were part of the actual design. Now, design patterns, if you look at what they're based on Christopher Alexander's stuff, I'm not going to go into the history and all of that, but there's one thing that Alexander does talk about. He talks about the fact that design pattern, it describes a problem which occurs in our environment, and then describes the core of the solution to that problem. And here's the kicker. In such a way that you can use this solution 1,000,000 times over without ever doing it the same way twice. I'm going to repeat that, because this is pretty awesome. So a design pattern is something you can use this solution 1,000,000 times without ever doing it the same way twice. Now, when I started learning design patterns, and if some of you guys have done studies in them, this never really came across. What came across was, here's the solution for, the visitor pattern, or the command pattern, or the strategy pattern. And it all came about from this. How many of you have read this book? How many of you have read it like cover to cover? Don't lie. I know it's like a matter of like, ooh, I've read design patterns cover to cover. It's boring. But it's the weird thing is that this is a catalog that came out of Eric Gamma's PhD thesis. So in the late 90s, along with all of the other craziness going on, the stuff ruining our industry, C++, you also had this catalog of these design patterns. And what happens, I don't know about you guys, but I just was like, woohoo, and started implementing singletons and commands and strategies and all of these crazy things. And so we would kind of look at them as Legos. We'd put them all together. How many people did that, have really built a system trying to put together design patterns? It's a lot of fun for a little while. But the thing is it never really worked to base our systems on it. It always ended up with this. And another thing that came about is it was another sort of wave of that who needs developers movement. Eventually, we can just use these patterns, plug them together. Developers can, go back. Business people can do it. Now, I love this idea because that means that I can just spend my day playing with my cat. Because if you don't need me, what do you need from me other than playing with the cat? And if you've ever even remotely stumbled upon my Twitter feed, you know that most of it is just pictures of my cat or other people's cats. But of course, it didn't happen. The whole thing about no developers, it's a constant recurring massive industry troll of the world. Because I just want to believe that somewhere there's this core of, shadow developers, and they're like, okay, it's been 9 years. Let's put something out again and pretend that people aren't going to need developers. And then there's this big, massive media blitz, and rah! And then in come the developers. We save the day, as we always do. And it's just like, oh, yeah, we were just joking. It turns out programming's more complex than we thought. So, of course, you get this big pushback on that sort of heavy design usage. We we're always pushing, J2EE, don't do that stuff, all of that stuff's enterprisey, which is odd since most of us work in an environment that it's heretical if you don't put your code in one of 3 places in a very concrete design pattern. I don't know about you guys. But, so we have this really heavy pushback. And this happens and all that. And at least for me, this was the early 2000s. And what happens, I start learning about evolutionary design. I get an extreme programming sort of boot camp style thing. I start doing TDD. I'm told, no big design up front and BDUF. And has anyone said BDUF in the last 6 years? 8 years? It's like, man, I used to say, every other word out of my mouth was BDUF. Back, probably around 2004, 2005, and it's just I'm not doing any of that. I do TDD. I do refactoring. I just let my design come out. It's like magic. It just flows out, and I let the test drive everything. Of course, deep down, there's this other sort of understanding about it, which is, I refactor. And it's true, I let my design come out from the tests and from the refactoring steps. But what is it that we actually refactor? How do we refactor? What does it mean to listen to your test, to refactor your way to the design? Of course, there's this book. How many people have read this book? Cover to cover? The true nerds have their hands up. This actually I found not boring, mostly. I found the design patterns book a little more boring, but the refactoring book seemed like magic. Because you read it and it's like, oh, hey, here's extract method. And you're like, wow, that's pretty cool. And then they're like, oh, yeah, and here's extract class. And here's inline temp and extract variable. And what I found, and I was working with somebody who was a relatively new to the idea of really strong refactoring. And they said it was amazing because they started reading this book, and they finally had words to describe what they'd been doing all along. It's like, you don't have to read the refactoring book to extract a local variable, or to inline temp, or I don't even know what those methods are, or all the terms. But this allows us to refactor, but there's still a question of when and how and all of that. And this guy, Kent Beck, how many people know Kent Beck? Everybody should have their hand up. If you haven't, not right now, but soon, go look him up. He's basically the father of TDD and one of the fathers of extreme programming. And in the late 90s, he codified what he called the 4 rules of simple design. Sort of these rules that if you abide by these, you will have a simple design. And I know it will be a simple design because it's by definition. These are the 4 rules of simple design, so it's got to be simple. So the first one, of course, is tests pass. Sort of that idea that, well, if you can't prove that your system works, it doesn't matter how good your design is. It doesn't matter how simple or complex it is. Nowadays, of course, we consider this to be a majority of it to be automated testing because our tool set is very mature. But it doesn't have to be. Sometimes it's, some little manual stuff. I just wrote a script the other day, had zero automated tests for this script. Don't tell anybody. But, I did some manual testing. It was, 6 lines long, so it wasn't too bad. The second one, of course, is reveals intent. You want your code to tell a story. You want to be able to go look in the system, go look in the code base and know where you're at. What are these methods doing? What's this variable stand for? I like to say that it's basically just good names. There's a lot more subtlety to it, but good names. If you just kind of spend a little bit of time thinking about that. And of course, names are hard. It's one of the hardest, 2 hard things in computer science, and I'm not going to say off by one errors because I hate that joke. The third one is no duplication, or as Dave Thomas and Andy Hunt coined in The Pragmatic Programmer, the DRY principle, the don't repeat yourself principle. Of course, a lot of times we look at this as structural, like, oh, I wrote the same code twice, let me extract it. But it really states that every piece of knowledge in your system should have one and only one representation. And by doing that, you end up isolating the knowledge. And so when it comes time to change your system, you don't tend to have the business come to you and say, I need you to change line 20. What they do say is, I need you to change the tax rate, or I need you to change this piece of knowledge in the system, whether that knowledge is behavior or whether that knowledge is actually data. And so by isolating that, by identifying knowledge and isolating it in one place, you end up with simple, or, as I like to think about it, just easy to change, because that's really a lot of what design is. And the fourth one is small. And, it's minimizing your classes, your modules, after you've already done the top three. And what a lot of us find is that if you really rigorously apply the top three rules, especially the middle two rules, you end up with a system that is small enough. It's as small as it's going to be. You can find a lot of these. There's a ton of discussion on the C2 Wiki. How many people have never heard of the C2 Wiki? Oh, wonderful. You guys are so lucky. Because it's like when you meet somebody at the coffee shop and they're reading Hitchhiker's Guide to the Galaxy for the first time. And you are like, you are the luckiest person in the world. Because, man, I wish I could go back and reread it for the 5th time. Awesome. C2 Wiki, it's at c2.com. Take next week off of work and just read. Amazing. This is where the discussions happened. All of the stuff that we do, all of the stuff that we take for granted, and we're like, I write TDD. All of this stuff was discussed on the C2 Wiki. So you're just going to see, it's wonderful, wonderful stuff. So one of the things that really comes out is that when we're refactoring, when we're looking to see what that means for our designs, what does it mean for a design to be driving or be driven by our refactoring, is really about this duplication. It's about finding the knowledge and isolating it. Of course, it's wonderfully easy to say that. I've said it many times right here. But doing it is more difficult. Knowing how to identify duplication. What is it? What is the knowledge? Where can I put it? And how do I eliminate it? What are the steps that I take to do that? It's not just always extract method. Like extract method, extract method. Sometimes it's extract class. But what are the steps that we want to do? How do we get there? How do we let our design drive out? So I've been talking a lot, so just to ease our minds, there's pictures of Zach. Oh. Okay, it's like a reward for listening to me. You see in Keynote, it's this long, long path of white slides. And it's like, oh, man, you got to rejuvenate with a picture of Zach. So getting back to this idea, we've already talked about there's been this pushback. We tend to badmouth patterns. Why do we study them? Is it worth even looking at them anymore? Or are they just, relegated to the Java enterprise people and we don't even have to think about them because, we're Rubyists and we do TDD and evolutionary design? So to answer this, I've got a few more slides, but if you don't like spoilers, you can close your ears. But yeah, it is still worth studying them. And a lot of it comes about from this book. Anybody read this book, Refactoring to Patterns? Oh, everybody's wonderfully lucky. This is a fantastic book. It's by Josh Karivsky. He founded a company called Industrial Logic. They do training and consulting. Wonderful book. Basically, what he did, I think it was published in 2004, and what he said is, we spent the 90s learning all of these design patterns and architectures, and we've doing all of these big designs, and we learned a lot of things about what works and what doesn't work. And then we come into extreme programming, which says, don't do big designs up front. Sort of start with small, build the simplest thing possible, and then let your design drive out. And there's this friction, this dissonance between that for people who were sort of at that era trying to figure out, do we just forget all about architecture? And so it's really that bridge between no design, which isn't what TDD and isn't what extreme programming says, no design, but the small design and building up your design from the design or the pressures that your tests give. And the other side, which are these patterns that we've memorized, that we've learned, that we've cataloged. And one of the core things, one of the core teachings is that design patterns, they give us direction when we're refactoring. I don't know about you, but sometimes I'll be in a place where I'm wondering, should I do this or should I do that? There's a couple different ways I could go with the refactoring. And so I go to this book and I see what they are and I ask which are the refactorings that I can do, but there are so many of them to choose from. And if I'm going to let this sort of iterative, evolutionary design happen, it would help if I was going in the right direction. I like to say that evolutionary design has one amazing benefit over natural evolution in that it has us sort of guiding the evolution as it goes. And so we can trim off things. We can choose the direction of what it means to be most fit. We can head towards a pattern. We don't have to implement the pattern. In fact, we shouldn't go in necessarily and straight implement it. But if we are heading towards the pattern, then we can look and talk about things. We can say, well, this is a visitor-ish. Because it is kind of, I've got this thing that goes through and there's a collection and it's kind of like a visitor pattern, and it helps highlight the thoughts that I have. So when I come to my code base and I see something like this, I can, oftentimes you go back and you go, what was I thinking? Why is it this clutter? This is kind of I'm looping over them and I'm calling move and I'm doing it on the children. I'm recursing. What was I thinking? But knowing that I was moving towards a visitor pattern at the time helps me see sort of where I should be going. How many of you have heard of the visitor pattern? Everybody should, because, Matt gave me a good introduction. So the nice thing is that you can look at code, you can look at somebody else's code, you can talk to your teammates and use this word. I use this all the time when I talk about designs, is that it's kind of visitor-ish. It's not there yet. It's not a fully baked visitor pattern, but it's good enough. It got me to solve the problem I was immediately facing in a way that I can continue to move if I need to, if I find that it doesn't satisfy all of the requirements that I have, or if something comes up later. Now, when I do this, I watch out for names. Don't go in and be like, oh, this is a move visitor. Don't try not to name your classes after the pattern that you're heading towards. Because as we all know from, children, witch and wizard stories, is that names are power. when you've stated in your code that this is a notes mover visitor, you've now bound yourself to it being a visitor. So you've bound it into where it's going. It makes your design suddenly a little more rigid. It makes your design harder to change. But if you just sort of have it be that sort of, well, this is kind of visitor-ish, then you're a little freer to shift the design, shift it over somewhere else. And that's good. That's a goal to have because we know that software is about change. Good designs, I don't like to talk about good design, even though I wrote it up there. I like to talk about better design. And better designs are always ones that are easier to change. Not configure, not a huge XML configuration file or YAML. I'm showing my age. But we want to be able to, when we find out what the change that's necessary, what's the change in our system, we want to be able to affect it. There are times, of course, that you want to do a straight-up implementation. Things like frameworks or libraries, where you really, really need the full benefit that comes from the communication. So like in Cucumber, it's nice if you're just like, okay, this is something that will solve this particular problem. I'm going to implement it. Of course, as we saw, implementing a full visitor pattern makes it harder to, it put a little bit of rigidity into it. But it satisfied the need for it for a while. Things like factory methods, some of these smaller patterns give you a lot of clarity, like this. What's this? I'm constructing it. So what are these parameters doing? What does this represent? It violates that second rule of clarity. So you look at things like the factory method. Usually it's considered around generating different types based on the parameters, but it also has things about hiding construction details and hiding the construction complexity. So we had all those parameters being passed in, and there was no good way to figure out what this was. So, sometimes we just do a simple thing. It's hard to have a partial factory method because it's just kind of a small pattern. So sometimes you end up with these full ones. Maybe you separate construction into another object whose responsibility is very clear as to what it does. So we all win a picture of Zach because that was a long, long push. Okay, we got a couple more, little more. So the question is, when we are moving, when we're pushing forward to it, how far do we go? How far do we move along the path to the design pattern before we stop and say, I've gotten far enough? And this, of course, is the ultimate question, and I don't have an answer for you, and you're going to leave completely disappointed. But here's an example. So I built this application a few years ago. We were working on it. It's basically sticky papers. So you move papers around on the screen, and by the name, if you put them on top of each other, they stick together and they move, stuff like that. So, of course, there's this question of how to implement this. You can do something, sort of an outside iterator that goes through and finds everything, and sometimes that's good. But the question is, how do you implement it? And you always can go back to this source. Studying the design patterns are worthwhile because then, when you do find yourself in a situation, you can make small incremental moves towards it. So we have a data structure. We want to traverse it, operating on each element. As I've said, visitor pattern. This is actually one of my favorite patterns. I don't get to use it that often, but when I do, I'm always happy. Because it just seems like it's this cool pattern. But you go look at design patterns, or you look at the visitor pattern, and it's like this, and then this one comes in, and there's this other diagram. And you look at Wikipedia, and Wikipedia says it requires single dispatch and method overloading. And you look at method overloading, and it says several methods with the same name. And you're like, but I'm in Ruby. I can't make several methods with the same name. I just want to traverse my tree. I don't want to have to worry about, I don't even know what single dispatch is. I don't want to go searching through Wikipedia, because clearly, while it is the sort of single source of all mankind's knowledge, it's completely I can't understand a word it says. So we can just head towards a complicated pattern. We can know that really what it is we're just trying to iterate over this tree, so we can slowly move towards it. We can start with just, having it inlined, of looping over them all and moving them. Then we can say, oh, well, we have to do the children, so let's extract out a method so that we can recurse over the children. Then we can move and put it into its own object, because we find that this one, the class is getting too large, and Sandy said I should pull out objects when my classes get too large. So we pull this out, starts to give us a little more. We pull the iteration into it. Now we kind of look, and it's like, well, the thing that's actually where the call side is, it's not so bad. And I've got this little bit of clutter there, but it seems to be doing what I want, and it's okay. And so we always ask at each step, can we stop here? Am I satisfied that I'm abiding by the 4 rules? Am I, abiding by Sandy's rules? I think so. Yes. Maybe. Yes. I'm going to say yes, and we can take it up later. So, can we stop here? And this is where I leave you all wanting more, because I don't have the answer. Sorry. But it really is about stopping and saying, is this enough? Does this give me the value that I need? And am I in a position where if I need to change it, I can come back in and change it? So, do I have the clarity? Do I have the intention being revealed? Do I have duplication that could be removed? Maybe, maybe not. And so it's always that question of, can I stop here? You don't want to overdo it. You don't want to over-refactor it. But, maybe you can. This is something, so if you take one thing away, it's really this. Start simple. Start moving towards the patterns, and every step of the way, ask yourself, can I stop there? Practice. Read the patterns. Read the refactoring book. Read refactoring to patterns. And think about this question all the time. Know the value that each step of the way is giving you. It all comes from doing it over and over again and seeing the problems that arise. Because the full implementation is often too much. This is why we had this big pushback towards these patterns. And just always head towards them. Use the patterns as guides while you go through the refactoring book. This is what I've been doing for the last, about 10 years. And to close it, read these 3 books. If you haven't read these books, go get them, read them. They are wonderful, wonderful. So anyway, since I'm the only one between us and a beach, I'm going to say that's the end. This is me. I work for a company called Wavetable. We're a business incubator in Chicago. I have a video series if you like this kind of thinking and this kind of talking. I don't have a logo or anything, so my default, if you hadn't noticed, is always just pictures of Zach. So you can go to cleancoders.com. I have a video series where we build an application and talk about these sorts of questions along the way. And that's it. We almost made it in 30 minutes. Thank you.
Hey, you.
Let's go.
So you said that it's worth learning design patterns. But don't you think that actually, maybe half of them are totally useless in languages like Ruby? For example, Peter Norvig explained that 16 out of 23 are useless in Lisp, what do you think about like Ruby and the languages that will come after? Maybe these design patterns will be totally useless later.
I do think I could see half of them being useless. Do you know which half? Well, there might be a few. So there are some. Like, never use singleton. It's horrible. Don't do it. It's just wrong.
What about config?
But no singleton.
What about
no singleton.
when you do application configuration? Would you use singleton for that?
No.
What, because you think you might load up some more?
I would pass it into my sort of root kind of thing.
That singleton root kind of thing?
No, I'd instantiate it. I'd pass it in. You only have one app object. Don't mistake.
If you've only got one of something.
Don't mistake one instance of the object with the singleton pattern. Those are two different things. Like going app.new, you only end up with one app object, but that doesn't make it a singleton. I know because I've read design patterns. But
Fair enough.
But more to the point, this was written in, they were collected from a language family that wasn't as much Ruby-like. And so, there's the saying that design patterns are just language smells, that they don't have it. I don't necessarily buy that on all cases. But knowing which ones are useless is pretty valuable to have it. So,
for example,
Avdi. Oh, sorry.
Do you have any suggestions for avoiding newbie pattern madness, where you read a pattern and instantly try to apply it to every problem that you have?
I think you have to do that, don't you?
Honestly, pairing. Pair with somebody. I don't see why. We all tell people when they're first introduced to design patterns, these don't try to build your system, don't construct, don't do everything, and everybody does. I did. They're like drugs. It's going to solve everything. But you pair with somebody who is experienced, they can help guide you through that. It's why I think design patterns are an advanced topic, not something that you introduce to people early on. Let people make the mistakes, build stuff up, and then go, hey, look, you've got this pattern. And then start talking about it. So, okay.
So I have a serious question and an even more serious question.
Okay.
You mentioned c2.com, where the discussions about design patterns took place. Are discussions around design patterns taking place somewhere?
I don't see a lot. They might be that I don't know about, but
Are we done with them? Have we discovered them all?
sure.
Well, when they first came out,
I don't see a lot. I don't see a lot of discussion around sort of bubbling up new patterns. I do think that there's a lot of discussions that if they took a step to the side, it would be about patterns. So a lot of talk about simplicity, a lot of talk about composability. There's a lot of stuff in there that could be extracted as a design pattern and made into, a catalog type of thing. But it doesn't have to be. It's like they're talking about things here, and then they just have to take a step to the left and call them design patterns. But whether or not there's any value in that, I don't know. But I don't think we discovered them all. I think every language has new and interesting things to do.
Oh, and also, why have you stopped using Comic Sans in your slides?
Why did I stop using Comic Sans in my slides?
why did you start using Comic Sans?
I used to program in Comic Sans. I did for a while, and it just makes you happy because it's beautiful. And then I gave a talk. I did use Comic Sans for quite a few talks, and it was kind of like trolling everybody. I was waiting for somebody to notice that I used Comic Sans in my talk. So thank you for noticing. But This one, I just used whatever's the default. Everybody hates, I always hear people say, don't use the default font in Keynote. But as you can tell, I love Keynote transitions, so the default font is the least of my problems in using Keynote. So, awesome. Matt had a question.
Yeah, I had more of a comment, really. So it was the thing about the names and the patterns. Steve Freeman, who is a big design idol of mine, a really good way to irritate Steve is to use the name of a design pattern when you're naming something. He really hates it. And the reason he hates it is because what you're doing is you're avoiding finding a domain name for that thing. And so the rigidity thing that you pointed out is really important, but also those design patterns come from the solution side. And if you get pulled into that and start using names like visitor or factory or whatever, you're forgetting about the domain problem and you're avoiding thinking about what the name is. So it's a really good discipline to try to do, to be aware of the pattern that you're using, but find a name from your domain that's meaningful. And it avoids pulling into that trap.
That's a great point. It's along the same lines as I hate manager. Because it's find what it actually is. Why do you have this class? And it's not to manage something. There's something in your domain that's causing you to have this. And I really like that idea of solution space versus problem space. And putting manager in there is entirely in the solution space because I don't know what this is.
And maybe that just means I'm not talking to the business people enough to find out what they would call that thing. So I just have to invent a solution-y name for it.
It's actually one of the reasons, actually I think it's more just a side benefit, that when I started using more, or allowing myself to name things with verb phrases, it allowed me to name things a little closer to that problem domain of instead of calling it, sticky note mover, I call it, what the thing does. What's its behavior? It moves sticky notes. And this idea that classes have to be nouns and we have to just, sort of pretend, put a blindfold on and just throw an ER onto the end of a verb just so that we can abide by this rule. I find it makes it easier to look at it in terms of the problem domain.
Corey, over.
Is that it? Oh, one more?
And then two at the back, and then one at the back, just in case you're wondering how the backlog's going.
Excellent.
So, over here. Hi.
Oh, there we are.
So we're at a Ruby conference, and so we're obviously going to be talking about object-oriented programming, because Ruby is very object-oriented.
That's what I heard.
And functional.
Yes, but with the rise of functional programming languages, after 40 years of being kind of on the sidelines, do you think that we'll start seeing more talk about programming patterns and functional programming languages or can all these design patterns be applied to functional programming languages as well?
I'm going to answer that with a caveat that I haven't done a tremendous amount of I did a tremendous amount of XSLT, which is a Turing complete functional language, but I haven't done a lot with the new stuff, so that's a caveat. It doesn't seem like that word comes up a lot, even though the patterns are in there. If you go through, the design patterns catalog, the examples tend to be like in Java or C++ or something, so you've got objects running around. But the thing that a lot of people don't read is the first part, which is this is the context. I have a data structure of varying types. The forces are, I need to go over them. I don't have a good way to change it. I need to be able to change it. That's a visitor. How you implement it doesn't have to be with objects or anything like that. You can pass functions around through it. And in fact, the sticky note thing that I did ended up being just functions passed around through it. So I would be surprised if you started seeing the term design patterns come up a lot in it, in the functional sort of community. But I don't think you can get away from the fact that there are patterns to solve problems.
Up the back, up the top.
Hi.
Top. Oh, there you are.
So why would you suggest to not use singleton?
Oh.
There, Cory.
How long do we have? Grab me tonight after a few beers.
Okay.
Or actually, grab Matt, grab Chris, grab anybody, and ask them. Everybody's got an opinion. Mine's right, but it's worth listening. So yeah, it's an interesting discussion to have about why it's bad. And there's no concrete, I mean, there's never any like 100% it's evil or something like that, although it is. But I mean, there's a lot of long history of problems with the singleton pattern. It's a global, I mean, that's what it boils down to, is it's a global variable.
Like
which
classes.
isn't always a horrible thing. Every constant, every class is a global variable in Ruby. And I use it a lot of the time. I mean, classes they don't have the instance off of it and things like that. So it tends to come along with all of the global variable problems. So use it very, very judiciously, and there's almost always an alternate way that you can solve the same problem, usually using some form of dependency injection.
Okay, thank you.
Sure.
Well, just commenting on what we were saying earlier about some patterns not applying to Ruby or some of the more modern languages. Don't you think there can still be useful as a communications means? Not necessarily. I mean, the application is built into the language, but you can still use the term, the name of the pattern, to communicate intent, even to people who do not program in Ruby, for example. What do you think about that?
I think that's a fantastic statement, that even the ones that you're not going to implement, the design pattern is that communication. It's saying this is sort of how it's working. And when you say this is, a command pattern, or, another one of my favorite is chain of responsibility. When you say that, people who've studied design patterns have an idea of what that means. I've got this long string of processors, and it passes down until it finds one that can satisfy it. And some languages have that already, but by saying that's what the thought process that was going through my mind when I was doing it, so I think that's a fantastic thought. And that's why it's worth knowing the ones that you think are irrelevant or unapplicable.
Would everyone please put all your hands together for Cory Hanes?
All right. Thank you.
All right.